Alright, so our next video here is section 7.3's Your Turn. So I want you to have already done this on your own, so shut off the video or the lecture here if you haven't already done it, and try it on your own. So what I see is a binomial squared. So I have my first term here, squared, a squared. And then my second term here, first times my second times 2. So plus 2 times a times r, and then plus my second term squared, so r squared, and that's my answer. Next we have a little bit more difficult problem, and I'm going to rewrite this one so it's going to be easier for us. We're going to have a negative 2x, and then I'm going to write that as plus a negative 7 quantity squared. And so now I can see this is my first term and this is my second term. So I'm going to have my first term squared. When I square a negative, I get a positive. Square 2, I get 4. Square x, I get x squared. And then my middle term is going to be plus, right? And then it's this term times this term. Negative times a negative is a positive. 2 times 7 is 14. X, and then that gets multiplied by 2. So I have 28x, and then plus 7 squared, which is equal to 49. And that's my final answer. So you see, by writing it as a sum here, I was able to make this a little bit easier problem. Now the next one I want to multiply conjugates, right? I have a sum and a difference of the exact same terms. So I have the first term, x squared, minus the second term, y squared. So x squared minus y squared is my difference of two perfect squares, which is what I get when I multiply conjugates. Now moving on to my next one, I also have a product of conjugates. So I have my first term here, squared, which is 4, minus my second term here, squared. Now remember, this is y squared squared, and y squared squared, that means I multiply the exponents. So y squared squared gives me y to the 4th power. Now some instructors and some books will tell you that 4 minus y squared isn't really how we should write it because it should be ordered, but it's more typical to leave that type of problem just like you see it there. Now moving on to part E, I have c times c, which is, c plus 1/3 times c minus 1/3, which is a product of conjugates. So again, I'm going to square the first term minus the square of the second term. 1/3 times 1/3 is 1 over 3 squared, which is 9. And so it's a difference of two perfect squares again, because that's what happens when we square or when we multiply conjugates. We get a difference of two perfect squares. And then finally, part 2, or problem number 2 of your turn, you're doing higher powers of binomials. So I'm going to rewrite this as 1 minus 2g times 1 minus 2g times 1 minus 2g. Remember that exponents don't quote unquote distribute. We don't have the 1 getting cubed minus the 2g getting cubed. That's not the way that we do this. This means expand out, use 1 minus 2g as a factor 3 times. And then we can see that we have 1 minus 2g times 1 minus 2g, which is squaring a binomial. So we can use the shortcut on that. Take the first term, 1, and square it, and we get 1. Then the product of the two terms, 1 times 2g, which is 2g times a 2, so we have a negative 4g, and then plus 2g quantity squared, so that gives me 4g squared. And then I'm multiplying that by 1 minus 2g, so 1 minus 2g. Now, because these are backwards, it may be a little bit more difficult for you to actually do these, but we can work through it. We can do it. So a negative times a positive is a negative, and that's going to give us 8g cubed. And then negative times a negative is a positive, and that gives us 8g squared, and it's positive. Negative times a positive is a negative, and that gives us 2g. Now moving over to the first degree term, the first degree term of 1 times a 4g squared gives us a 4g squared. And 1 times a negative 4g gives us a negative 4g. And then finally a 1 times a 1 gives us a 1. And now we have 1 plus 0, which is 1, negative 2 and negative 4, which gives me negative 6 g's. And then we have, let me make sure that this is a positive. That came from that one, so yep, that's a positive. See where we need to always make sure we put in those signs. 8 plus 4, which is 12, and then those are g squared, so 12g squared, and then minus 8g cubed. And that's our final answer. Now that one's not ordered, but it's very typical to leave them just as you see it here, because this negative, if it were out in front, it would have a tendency to get lost. And so you'll see them written in non-ordered form just to avoid them getting lost. All right, our last one, remember when we expanded that out the last time? What that ended up looking like was a plus 3 squared times a plus 3 squared. And therefore, we're squaring a binomial and squaring a binomial. When we square a plus 3, we get a squared plus 3 times a times 2, which is 6a, and then plus 3 squared, which is 9. And we're multiplying that by itself, a squared plus 6a plus 9. And so when we multiply these, it's easier to do it with long multiplication. So 9 times 9, we have 81 plus, and then 9 times 6 is 54. And so that's a 54a. And then our next one, that's a plus, don't forget the plus, 9 times a squared, 9a squared. Moving over to the a term, 6 times 9, that's again 54, and that's a. And then plus, and 6 times 6 is 36, a times a is a squared, and then 6 times a, 6a times a squared, which is 6a cubed. And then finally moving over to the a squared, 9 times a squared is 9a squared, that's a plus. And then a squared times 6a, which is 6a cubed. And then finally plus a squared times a squared, which is a to the 4th. And now we'll go ahead and add all of these. So we get a to the 4th plus 6, which is 12, a cubed, and then plus, we have 9 plus 9, which is 18, and then plus 36, so we have 4 carry the 1, which is 54, a squareds, and then plus, and 54 plus 54, which is 108, a, and then finally plus 81. And now we're almost done. And I'm going to actually do this last one as well, even though it's not in our examples that are your turn. So this one uses function notation. And the thing with this last one with the function notation here, we're evaluating, right? So you remember, if I want to find f of a minus, or excuse me, plus 1, for this value, that means everywhere there's an x, I'm going to put in an a plus 1. So a plus 1 goes in for my first x and ends up getting squared. Then minus a plus 1 goes in for the x, so I'm going to end up subtracting that, which is distributive property. And then the next one, we have plus 2. And so there's no substitution there. So see how this applies our squaring. So this is 2 times a plus 1 quantity squared, which is a squared, plus the product of these times 2, which is 2a, and then plus 1, and then minus, and then this is going to get distributed here and here, so minus a, minus 1, and then plus 2. Now we'll go ahead and distribute this one, and this one. So we have 2a squared, and then plus 4a, and then plus 2a, and, oh, not 2a, sorry, just 2 there. And then we have minus a minus 1 plus 2. And now we'll want to combine like terms. So there's only one a squared term, so I'll write that down, 2a squared. And then I have a term here and an a term here. So I have 4 minus 1 of those, which is 3 a's. And then I have constants here, here, and here. So 2 minus 1 is 1, and 1 plus 2 is 3. And so there's my evaluation. F of a plus 1 is 2a squared plus 3a plus 3. And that finishes chapter 7.3.